Hi, I'm Destin Ronada, a representative of Team JDE 8349. In this video, I will be demonstrating the functionality developed with our script during Sprint 1. Before I get into sprint-specific developments, I first want to give a general overview of our approach so the developments make a bit more sense when I go over them. If we fundamentally break down the functionality of our conversion script, there are three key features we want to focus on. The first is to read the HL7 file, which is our input, and parse it into individual lines, where each individual line is a relevant segment of the HL7 message. The second feature is to break each individual segment up into its respective fields, components, and subcomponents, and then place that broken down segment into the proper level of the JSON hierarchy, as specified by documentation that you'll see later in the demo. And the last feature is to simply write those JSON objects to an output file. So for Sprint 1, we focused primarily on developing a script that would have all three of these key features at a baseline level. Features 1 and 3, which is reading from HL7 files and then writing to corresponding JSON outputs, are both relatively simple and are fully developed as of now. Feature 2 is by far the hardest to fully implement, and that is what most of this demo will be about. First, I'm going to run our script. This is the designated output for our code, and we are reading this HL7 file here, onetest2774.txt. It's essentially just a plain white text HL7 file. When I run the script, it will generate a JSON file with the same name. The script is run. I am going to compare our outputted JSON file to our expected output that our client provided us. I already have it open right here. So I'll start with the header portion, which appears at the beginning of both JSON outputs. The header contains both the message header and software segments of the HL7 file, as you can see here. Software segment and message header segment, same with our expected output. And our script currently has fully breaks them both down. And they're the only two segments that break down fully as of now. So you can see that these portions between our output and the expected result are virtually identical to each other. So there are a ton of segments in this HL7 file, and I'm not going to go over every single segment in the message, but essentially our script currently breaks each one down into its respective fields and stores them accordingly in the JSON output. For example, I'll just take the next of kin segment here. It has all of its fields properly stored, so NK52143. But unlike the message header segment that you saw above, or the next of kin segment that is in our expected output, it doesn't break those fields down any further. Another feature our team developed is that our script accounts for segment repeats. So right here, the OBX segment is one that repeats a lot, the observation result. This usually ends up happening because there are multiple ordered tests on a single specimen. Normally, you wouldn't be able to store these segments, the multiple segments, in the same JSON object because elements of JSON objects have unique keys. So we have to code around that. Lastly, a feature that's currently a work in progress is the established hierarchy of the JSON output. So our JSON output is essentially designed to mirror the abstract message syntax as described in ELR documentation sent to us by our client. I have it open right here. And so I'm going to compare it to our output because essentially this is what we structured our JSON output to be like. So currently the header level of our output contains the SFT and MSH segments that you saw earlier. Right here, SFT, MSH, all under header. So that's all correct as of now. The rest of the segments, we currently have them dumped into the patient result level, which you can see is the next hierarchy level for this. During Sprint 2, we will make sure that the rest of the segments that we have are arranged in their proper levels. So that's all the functionality I have to demonstrate for today. Thanks for watching.